Welcome everyone to the Terra Confluence 2024 series, where we at Global Climate Association are inviting members of our community, climate and environment community, who are relentlessly working towards a better future. So today with us, we have Steve from Australia, who is representing PSKL Systems, and he'll talk more to us about that. I'll share the introductory video for everyone to see. So, Steve is a key contributor to our one of the highlight events, that is the Terra Torrents, a dialogue series aimed at bringing climate solutions to light from visionaries across the globe. Steve, based in far north Queensland, Australia, brings his extensive expertise as an earthworks machine operator and permaculturalist, and is the creator of maximum infiltration strategy for landscape rehydration and regeneration. His passion for sustainable soil and water management is a vital contribution to our discussions on innovative solutions to current challenges faced by Earth and the environment. Steve, we all welcome you here. The floor is yours. Please share your thoughts with us.
Thank you, Paloma. Great to be here and to share with everyone. Thanks for the opportunity to share what we're doing.
Yeah.
So I've got a little slideshow here that I can detail what we're up to. How's that? All good there?
Yes, it's great.
Great. So I'm co-founder of an Australian land regeneration startup company, and we work to reduce drought, fire, flood, and changing climate by rapidly restoring water cycles. And we're unique in that we're integrating unpowered technology with ecosystems, living systems, trying to accelerate them and optimize them and use these simple tools to bring back what we need to. And here I just want to go a little bit macro and describe some of the big challenges we face and then describe our place within that. So I see three possible climate and energy futures: green growth, the green transition, which is a lot about renewables and electrifying; degrowth, an energy descent future, where we make do with less; and regrowth. So regrowth is working with living systems and self-replicating systems, and that's where our emphasis is and where we believe the big potential is. So some of the unspoken challenges that are not in public discourse in green growth. So green growth assumes that we can continue to live the lives we live, very energy, a lot of energy use, the same lifestyles we have. But there's a couple of professors that pose challenges to this ideology. Nate Hagens is a professor. He has the Great Simplification podcast, a fantastic podcast, sort of unpacking the nuance of climate and biodiversity. So he says that more accurately, renewables should be called rebuildables. And they're called rebuildable if we're clever in our manufacturing and engineering, that they can be put back together in a cost-effective way or recycled in a cost-effective way. Currently, most renewables aren't. So only about 30% are. So the majority of it is going to end on a junk pile or in landfill. So we need to be really intentional, thinking through cradle to grave, thinking through the energy return on energy invested. It's super important. Otherwise, we're just using our intellect, energy, resources, and not making the most of it. And renewables will be a real important part of our energy future. Professor Simon Michaud is another guy. He's a mining geometallurgist. So he's a systems thinker for mining, thinking through all the different process, thinking through the different impact of things. His research says that we don't have enough key minerals to electrify the first generation of a global fleet. So he thinks there's some massive shortcomings in our strategy currently. So I've spoken to some guys within Australia on, is Australia aware of this? And the feedback I got was, no, this is a huge gap within Australian understandings of where we're moving as a country. And Simon Michaud does present to the UN and different governments, but it's certainly a narrative that we need to understand a whole lot better. So the degrowth movement is an energy descent future. I think realities on the ground this will play out to an extent, but I think that degenerative ecosystems, when they're degenerating in a degenerative spiral, you sort of have a drought, fire, flood cycle in Australia or in other parts of the world, Mediterranean, Spain, parts of the MENA region, they're in this degenerative spiral. And even if we have a degrowth narrative, it still continues to degrade. So I think there's a lot more potential than is understood there. And that's why we're talking about a regrowth paradigm. And this is just an idea that we're testing, and we're hoping to promote it and get as much airplay as a degrowth paradigm, saying, well, we can actually steward ecosystems in a way that's rapid, compounding, has great climate benefits, has a carbon drawdown, biodiversity benefits, and we'll get into that a little bit more. So that's what we see as a really exciting aspect. So we all know that water is the engine of life. Water is super interesting in that water doesn't disappear. It changes phases, it changes locations, and how we steward the land is a really important determining factor on how the atmospheric moisture and moisture from the oceans can participate in the land. We're currently having rising sea levels. We have positive feedback loops in atmospheric moisture, in a warming atmosphere holding more moisture. So we're getting more extreme weather events, more extreme snow events and rain events. So our land stewardship's really key, and that's our focus at the moment. Brock Dolman's a fantastic permaculturalist. So a lot of rehydration and regeneration landscapes, it's super simple stuff, and yet we don't do it enough. So it's slow it, sink it, spread it, store it, share it, and you can rehydrate landscapes. And we're bringing some additional aspects and some aspects that really speed it up. So we're bringing in unpowered aerobic timing. So it's like having an irrigated garden on a massive scale. We're bringing in really fantastic pumping elements for gravity irrigation and an energy creation element. So that gives us a whole heap of different options that we've been continuously coming up with new applications for variations on this different technology. And we'll get into that shortly. So this is a quick video it's not complex stuff, but it's different enough that it's great to show people a video so they can get their head around how we're working with ecosystems.
How can deserts be transformed rapidly into rainforest? Deserts have rare rain events and can experience extreme runoff when it finally does rain. Evaporation is very high. We can capture extreme rain runoff in long swales and store it in a dam. We can then release the water to a fuelless pump that pumps water to higher water storage. The pump is powered by water. A percentage is pumped and the majority is discharged. The pump can be turned on and off with the high flow, unpowered evaporation activated valve. This means that the discharged pump water is never too much for the soil or plants. The valve doesn't need electricity, internet, or Wi-Fi. It is a reliable low-tech innovation, making it ideal for remote sites and tough conditions. The pump is self-regulating and self-priming. By providing regular moisture at appropriate rates over large areas, plus fuelless pumping, we can rehydrate and regenerate deserts. We can increase infiltration time by 100. This means pioneer plant species can start growing and soil can be improved. The rapid improved water cycle will help regenerate at the fastest rate possible. This enables supercharged plant succession. Rapid recharge of groundwater with rain improves groundwater quality and raises the water table of the surrounding area. Fresh water is less dense and sits on top of the poorer quality water. Trees and vegetation can also regulate the water table and salinity. The best place to store water, store carbon, and grow food is in the soil.
Next slide. Yeah, so in reflecting on that was the initial strategy. We call that one maximum infiltration. And I sort of approached my co-founder and we started looking at different possibilities, and we realized there's a whole lot of different applications. For instance, polluted river remediation. You can move water, move it through designed wetlands, physically filter pollutants, and then biology can filter things, and then it can be fed back in. There's also, you can move water around on different sites. For instance, regenerating on the windward side of a mountain has a moisture multiplying effect that you don't get on the leeward side of the mountain with the orographic effect. So we thought that was super interesting that people can be moving water around on site. Fuelless pumped hydro storage is also very interesting. Pumped hydro storage has the highest energy return on energy investment anyway, currently, and it's 99% of energy storage at the moment. If you're able to do that fuelless pumped hydro storage, we're enhancing the water cycle of that area and ensuring even more rain on the catchment, make it more moisture, and water-powered pumping makes it even more interesting. Infiltrating and pumping snowmelt. Normally you can't do that because the ground is frozen. So in some cases that could double usable water and can increase things like snowpack and things like that with the orographic effect. So there's multiple ones. There's also a water relay idea that we have where instead of releasing water into the landscape on landscapes with high evaporation, you're actually containing the water in a pipeline and these little concrete structures, and you're able to utilize the discharge water each time because the majority of the water is discharged each time. Also at these concrete structures, you can add water at any point and you can take water out at any point. So you could have a dozen of these in series and be able to pump the discharge water a dozen times. So this is just a rough idea of what these very simple concrete structures could be with a water-powered pump in the middle. And it can be great for bore well discharge. You might have an area in the landscape that's suitable for bore well recharge. You're wanting to raise the water table. Fresh water is less dense than the more brackish water, and it'll sit on top. So water will be improved as the water table comes up. So you can sort of choose your areas there. General features of the pump, we have a strong preference for simple, reliable, low-tech, anti-fragile, bulletproof, tough design, and then working with living systems. The Bunyip pump, the core technology here, was first invented 20 years ago in Australia, and it's been innovated on since. One of the pumps with sort of an optimum flow rate can pump to a really impressive 750 meters elevation, 1000 PSI, which is fantastic. The pump is long-lived, can be serviced by the pump owners, needs a minimum of 30 centimeters fall. It has a unique feature that it can, the pumped water and the supply water that's powering the pump can be different. So you can have two different water sources being pumped, so that creates a whole lot of flexibility and adaptability. It's like having irrigated garden on a massive scale, which makes it really exciting, especially people in brittle climates like myself, or in India, or a lot of the world, and increasingly so with places drying out due to land use. Really, a lot of deforestation is changing weather patterns for places. So, for instance, where I am is a landscape with a lot of water catchments with 80% runoff. So between the slope and the soil type, that's how much water runs off. So it's really exciting if we can change that to 100% infiltrated and pumped within the first year. And then we have compounding rehydration each year. And there's a whole lot of other multiplying effects like soil structure improving, or increased life means increased nutrient, means increased growth, more evapotranspiration, more aerosols, etc. So there's a couple of dozen things to get your head around. So it's great to have that Earth systems thinking framework to understand that we're dealing with an ecosystem. We're not dealing with carbon, or we're not dealing with water. It's everything. So in terms of climate change, we're excited that if you implement it on a large scale through the rapid and compounding rehydration, you can change weather patterns. And the more runoff on a landscape, the more rapid the change and the more impressive the results for that. So we've got some different animations here, the desert to rainforest we've seen. We've got one which talks about what we mean by the 100-fold increase in infiltration time. And then we've got one for harvesting snowmelt. My co-founders, Ali, Myra and myself. Ali is introduced permaculture to Pakistan. He's a mechatronics engineer. And Myra's got fantastic business and finance experience. And yeah, I'm Earthworks machine operator and landscaper in far north Queensland. So yeah, we see these strategies as really exciting to get from degraded to regenerated rapidly through using water, and then the ecosystems will express themselves. And those who get most excited about what we're doing are the climatologists and the ecologists and the hydrologists. So they're super engaged very quickly. And we're looking to collaborate and develop projects in many parts of the world. And we think that's what we need to do. We need to, time for actions now. We need to collaborate on all sorts of different projects. That's how things will get done. And then briefly, I have some pump efficiency examples, but I think I'll jump to some other questions at this stage. Yeah, thanks, Palumi.
Thank you so much, Steve, for sharing your work with us, because this is very innovative. And the fact that you are working with people all around the world to develop this system means that we need all decks on hand for climate action and environmental issues that are facing us. So I would like to ask a few questions to you, if you are up for it, on the work that you're doing and on PSKL system. So the first one is, considering that PSKL is a land regeneration startup, could you share what inspired the initial focus on water management for climate action, and how this vision has shaped the conceptual methodologies of PSKL, KL, Water for All? Like, you are from Australia, you might be facing some certain issues, and then Ali and your other partner Mahara is from Dubai, I think, and then you might be facing some sort of a similar issues that you wanted to club together and make this happen. Could you share some insights on how this came into being?
Definitely. So for myself, a decade or a bit more ago, moved to this dry tropics landscape, and I was talking about the 80% runoff. So each year I see my organic matter and my topsoil disappear and the gullies get a bit bigger. So that created a strong interest to learn about permaculture and regenerative agriculture. And the aspect that really excited me was learning that in how we steward and manage the landscape, will either degrade our topsoil or grow our topsoil. So that really excited me, learning that you can actually grow topsoil through your management. Equally, as I learned more, I learned that you can enhance through good management or degrade water cycles. And then from learning initially about permaculture and regenerative agriculture, I got more and more involved in the more technical climate side, getting into learning what environmental physicists were talking about, like the biotic pump that I've seen you're having a look at. Bioprecipitation as well, the aerosols from forests. Some of them being really interesting, that they're actually having a cloud condensation at lower altitudes and warmer temperatures. So they're actually creating cloud more easily. Super interesting that forests can do that. That's a particular hygroscopic bacteria, Pseudomonas syringae. So in relation to climate, yes, I realise that water and our land stewardship is a really key part. Carbon is an aspect of it. And in terms of how carbon relates to what we're doing, well, carbon is a building block of all life. So as soils develop as plants sequester carbon. That's the carbon element. And then there's also a cooling element of regenerated ecosystems as well that have so much biodiversity, productivity benefits. So yeah, that's what excited us, that it sort of ticks so many boxes. And then you definitely need that Earth systems thinking framework. You can't myopically look at one aspect. Yeah.
Sure. Thank you for answering that question. It makes a lot of sense when you say it in that way. Also, you have a lot of knowledge when you have worked on the field and you're integrating all these systems, like from earth system to water management to ecosystem ecology. These are all very diverse fields, and then you are putting it in field and you're actually working on it. That is a great, I mean, like achievement actually. So, moving on to the next question. As PSKL's unpowered technology, particularly the water-powered Boniwell pump, has been around for roughly 20 years, can you describe its evolution and how its established applications contribute to climate change mitigation? In the sense that if it has, that technology has been there for such a long time, has that not been really adapted yet, and why that may be the reason? And if you could shed some light on that.
Yep. So the normal application of the bunyip pump is in a flowing creek. And a lot of these innovations and ideas are pretty pioneering. So not much has been done on large scale. Also, we see application of not needing any existing resources. You might be dependent on the topography of a land, and you could introduce bunyip pumps into a system where there is no other water resources. So that's a different application to how the bunyip pump's been used previously. So it does open up the possibilities for the bunyip pump. Yeah, so it's fairly innovative. We're sharing ideas, we're getting feedback, we're looking to connect with different people, especially people with extensive large project experience. We're really keen to connect in with them and enhance their designs.
So I have a follow-up question on the part of the banyan pump part, that if that structure that you showed, like the landscape, it was quite barren and there were no interruptions or infrastructure in between. Will the system still work if it is on a urban scale? If there's urban built up there and then we are lacking groundwater, say for like in the year 2030, a lot of parts, especially in case of India and many parts of the world, there's supposed to be a acute shortage of groundwater. And can this system also not only work in open areas or wooded areas or deserts, but will it be effective in case of urban setups also?
Yes, I think it could be. It would look a bit different, and each site, the simplicity of the bare forest, the bare landscape that I have in animation makes it easy to understand the strategy. When you're in a city, there'd be all sorts of complexity and probably a lot of different other elements that you'd have to understand. But yeah, absolutely. So maybe with parklands or things like that, you could have different elements. Or if you are not wanting to release water at certain points, you can enclose it like we have in the water relay, and then you pipe it onto an area that is appropriate to do that. So yeah, I think it is certainly a very rapid way of raising groundwater and groundwater quality.
Sure. With I'm moving on to the next question now. With PSK's methodology still being conceptual, can you discuss how they theoretically approach water cycle restoration and their potential impact? Mostly, I want to say on the ecosystems, because there were the visuals at the presentation that you showed us. It stated that it can actually get the pioneer communities of plants to start setting up in that situation, in that landscape, if the restoration project it works. So is that something will have like foreseeable ecological benefits in the future, do you think?
Definitely. Yeah, in terms of implementing, all plants have their little ecological niche where they thrive or where they're trying to improve fertility or hold soil together or penetrate soil. I think the interesting aspect from a permaculturalist or a land designer's point of view is often in designing a site, you would think, what is the optimum biome that's existed in the past? Therefore, I'm going to move towards that. I'm going to have my pioneer species, climax species, etc. The interesting thing about what we're doing and potentially the challenge is the speed of rehydration is extremely quick. So you may want to even slow that down, and the compounding effect as well. So I'm not 100% sure what the endpoint is, but you might end up with huge forests with a lot of moisture, with a lot of fungi, if you have that compounding effect every year. So I think that's a really interesting aspect from a designer and an ecologist point of view. What is the endpoint if
Hmm.
it keeps compounding?
That is actually interesting. We have to wait and watch what happens when the forest in these systems set up in the future. That's
Mm.
great. So, moving on, what are the challenges do you anticipate in implementing these technologies in varied geographical landscape? One of which we discussed about if there are urban infrastructures present, and how might you adapt these conceptual methodologies in different environmental conditions? Say, Australia has a very different climatic condition, the topography, the landscape is different than Pakistan or India or Dubai or perhaps Africa. So, have you given any thought how these technologies might be implemented there when there are different landscapes?
Yeah, we are still conceptual. I think every site and project we do will gain important lessons, and it'll
Hmm.
be important to make note of that, to recognize the patterns so that we can be quicker in learning and modifying our strategies for future scenarios. And perhaps AI and machine learning could aid in that as we hopefully scale and get bigger and things like that. There are ecosystems always have surprises, whether it's soils who slump or don't do what they're doing, don't do what other soils do that you're used to from your context. Or Ali, my co-founder, was giving me an example the other day where there was some places in Pakistan where the natural mineralogy was toxic for groundwater. And I hadn't really considered that before, that in implementing a strategy there, you'll be looking to keep groundwater above these natural minerals that have that toxicity. So I think, yeah, every site will have its own lessons, and certainly understanding the key concepts of increasing infiltration time or pumping or movement. They're the key concepts that we want to get across to designers, and there'll be all sorts of nuance within every project that will be important to understand.
True. Because what Ali says, I totally agree with that because a part of the northern Indian plains of Ganga River has a groundwater issue of arsenic being found. So deeper you go and the wells are dug and there is like deposits of arsenic all around the fluvial belts of the river, and it gets
Mhm.
infiltrated into the water system, and it has some impacts on the health of the people. So I think point by point, when the as we do more research on your work and it moves around and more implementations are done project after project, you'll have more thorough ideas on how this is affecting. So that
Mm,
is good to know.
definitely.
Uh, then moving on to the next question, for this is something related to engaging communities in these projects. How does PSKL envision involving local communities in your future projects? And what strategies are planned to ensure these initiatives are sustainable and meet community needs? If you have some thoughts on that.
Yep. I think engaging with communities initially and having the ongoing support of communities is the determining factor between success and failure long term. I think it's really important that the project's aims benefit the people.
Hmm.
Like, for instance, I'm thinking of a scenario where there may be a carbon project that's implemented somewhere. and the benefits are benefiting a corporation elsewhere, I think it's very justified that a particular community would be upset and not supportive of that. So the fertility, the increased water, the biodiversity, the community, the local community needs to be focused, even if there is a carbon project, other element. In terms of developing those aspects, there's a group called United Designers who do big projects up to the scale of the UN, and they've got fantastic experience. So we're keen to collaborate with those guys and learn from their process with engaging with communities and stakeholders, and a lot of the complexity is this. There is all sorts of complexity in projects, and the bigger the project, the more complexity.
True. So thank you for sharing those thoughts. Then I would like to move on to something more on the levels of policy, that what kinds of policy support or collaboration from governments could be beneficial for a PSKL mission, considering this is more of an international project than on a local or regional level. And any ideas on that? What sort of support do you expect from the policymakers?
Yep. My hope is that policymakers could see the rapid benefits for them, for their people, for their productivity, for their tax base, for their mitigation of extreme weather. So they would be quite receptive in their regulation and policy. In developing countries, regulation of existing watercourses is quite time consuming and costly. Speaking to the Australian context, can even take years and can be half the cost of a small project. So I think in some developing countries that may be a little bit easier. The regulation side, my hope is that all countries can see the benefit of it, and regulation is important but sometimes it can get in the way of beneficial projects as well. So I hope that there would be accommodation for beneficial projects.
True. Especially in cases such as in countries like India or Bangladesh or Pakistan, there are a lot of, there are a lot of ways that you can come and start a pilot project and you show the government this is working, and maybe when that does work in developing nations, then you can bring it forward to these other countries that are more maybe difficult in accepting the
Yes.
policies. And the more we share about this new ideas that people like you are doing, I think the more of it will be helpful in the future for it's like in a long-term level, I can say. Moving on to now to the some other part of the discussion which is not really related to your work, but we at the Global Climate Association have a focus of women in STEM, like technologies and engineering. Could you share any PSKL initiatives or any plans for you to encourage women's participation in climate technology and innovation, especially within the realm of your startup's scope?
Mhm.
Have you
Yep.
any thought of this as something that you would like to do?
Definitely. You can sort of tell that our initiative is ecology focused rather than technology. Even though we're using a little bit, we are very ecology focused. So people in the earth sciences field would be fantastic to engage with them. And it's the self-replicating nature of life that we're really attracted to, whereas the technology that needs to keep being implemented, that we see that has some shortcomings. Yeah, engaging with women in the STEM field. Yeah, I think there's all sorts of possibilities. We'd love to engage with hydrologists and climatologists and ecologists. And we think broadly women can benefit from what we're doing with the simplicity of being able to deliver water. Women spend millions of hours every day walking, fetching water in parts of the world. And we think that instead of just digging wells, which are important as well, but we can also improve weather patterns and build fertility on site where people are, which is sort of that regenerative upward spiral. So we think we can definitely help women and children, and there'll be all sorts of opportunities for women in the STEM fields as well. And it'll be
Sure.
fantastic. Mm.
So, yeah, I think you were right when you said, like, especially in case of developing nations, like India is one of them where the work of getting the water is on women. Men are, if they are farming, especially in rural areas, so they have had to walk miles to get water from far off places. Now the situation is much better, but it's worsening because of the lowering levels of groundwater in the bedrock area and all that. So that is why we need to have more, I mean, like everyone should be involved in this process of making things better off. And in the field of I know in field of research and all, women participation is there. What about on field? I mean, like you have a more experience on working on field with the actual with landscapes, and for the parts of the world you belong to, are there women big part of that community where they're working on the field?
Yeah, I've got friends who are doing amazing things, who are agronomists, ladies, and real change makers. So up where I am in the Atherton Tablelands, definitely there's a female force doing amazing work in regeneration, which is great.
That's
I
great.
think, yeah, I think sometimes the stubbornness of the male farmer up this way can get in the way. I think females and younger people are a lot more receptive to ideas, and surprising, like despite the results of farmers doing regenerative agriculture and having higher profit margins, there's still incredible resistance to changing practices, which will change over time.
It will change slowly. We have a bunch of speakers lined up who are working, females who are working in the field of regeneration and ecology and different parts. And so we are happy to promote that idea also. Then
Right.
there are a couple of questions regarding can educational institute, I mean, like, how can educational institutes or research institutes engage with PSKL at this stage? Because I say this because your idea is going to go out on our platform and maybe many people will reach out to you. So have you any idea how this PSKL system of work of regeneration and rehydration will help in creating sustainable water management methodologies in the field of in the field of education as well, so that people study these from basic, like in their education they have these systems, they know the system so they can implement it themselves. Do you
Mhm.
think any initiatives like these will be something that you would support?
Definitely. We'd love to hear from institutions and universities. So you can reach out to us at PSKL Global, which is on there at the moment. Often people may, be doing PhD research, or they may have certain things they want to study. We're quite happy to engage with people there. They may have certain areas that they're keen to regenerate, and that not only provides them a project and our methodology, but it provides us a landscape to do things. So that's really a win-win situation there. I think in proving out the different strategies, we'd love to do that initially for the different strategies, and there may be other conceived ideas as well. Then I think once we've got them proven out, I don't think we will be looking ongoing to keep demonstrating them, like keep monitoring them and whatever. Like the ecosystems will express themselves. So we'll just concentrate on scaling
Hmm.
the simplicity of it and benefiting villages and communities in rural areas that really need it most, I think. So definitely initially, we would
Mm.
love to hear from people and develop that.
And that will actually, if you have like collaboration with educational or research institutes, it will give them the new thing to work on, and they can means research, and you will get more validity of the work that you are doing, what to do, how to evolve it, and so that, as you say, it will be a win-win situation in that
Definitely.
case.
And we don't have that capability. We don't have the expertise that these university guys have, or the equipment, etc. So it'd be fantastic to engage with them.
That's great. Yes, that is true. We need collaborations on all level to make any enterprise happen. So, and this is something which is very important for not just as a company or as for a few individuals. This is something that can change the entire ecosystem. So it is like definitely worth working on.
Mhm. And
Uh,
exciting too. Just uh, exciting and new and innovative. So I think it should be quite attractive to people. Mm.
Exactly. Yes, people jump on any ideas that is happening, and then they want to test it for themselves whether it's working. Especially, I'm from a research background, and people, they find these innovative ideas and then they go into the labs and work on it in different levels so that
Mhm.
they can better it actually. So I hope this also gets this tech your technology also gets something that is picked on by the people and to work on. Mm. Now a little bit about the future. What are PSKL's immediate goals and plans, particularly in terms of establishing projects worldwide? Could you highlight any upcoming collaborations that you're or any initiatives that you're excited about?
Mhm. Yep, we have some initial involvement in a couple of projects, very early stage, but these are large projects. One, we've done up some conceptual plans for a large regreening project in the Sinai, which has a very complex geopolitical um, dynamic. So it's sort of on hold, but there's a really exciting Sinai project which aims to regreen the Sinai, change the wind patterns from and it'll change potentially weather patterns in the MENA region and parts of the Mediterranean through that particular area. So super exciting project there. And we've involvement with a Panama Canal watershed restoration. You might be aware that shipping is about halved because they don't have enough water in their lake there for the shipping to move through. So the Eco Restoration Alliance has a joint proposal for that. So it's early days for that, but we think we can add some exciting aspects to what the other initiatives within there are doing. And yeah, we still are at early days. So we're keen to engage with projects. United Designers do get approached for projects, and we may hear something through them. But if anyone has projects, please hit us up. We'd love to develop them.
Sure. So eco restoration alliances, the ideology is like green up to cool down. So that aligns very well with your idea of rehydration and regeneration. So I'm pretty
Absolutely.
sure like there's no better time to start. So we have to start somewhere. So as we develop our systems of collaboration across the world, we hope to make this happen. Also channelize the people from all across to make it more effective in implementation.
Mhm.
And this will be my, I mean, last question to you. From your current perspectives as a land regeneration startup, what advice would you give to students or professionals looking to innovate in the field of climate sustainability and resource management?
Mhm. For me, definitely having a Earth systems framework or a systems framework, understanding the interconnection of different elements and the patterns, myopically focusing on one thing and thinking that that's the silver bullet solution, you'll draw the wrong conclusions, uh, whether that's carbon or soil or different elements like that. You really need to understand the ecosystem as a whole. Also, collaboration and across disciplines. I think it's really important for academics and researchers to be open to engaging with others and saying, oh, I want to know a bit more about that. Developing things, testing hypotheses, innovating, innovation. Sometimes you're wrong. You might test an idea. So I think in the early stage of the presentation, I pointed out in the green transition that we've got these exciting technologies, but we haven't necessarily optimized how we go about implementing it. So I think taking a few steps back, maybe asking questions and delving deeper is really important in moving forward.
True.
Yeah.
We have, sorry, please continue.
Okay, I just thought I'd add another element as well. PSKL, we have an emphasis saying that the best place to store water, store carbon, and grow food is in the soil. I think soil's a really key element of food production, in that the same organisms that change dirt into topsoil are the same organisms in our gut health, in our gut microflora. They number somewhere between 1 to 1 with every cell in our body, or 100 to 1 with every cell in our body, somewhere between that. And there's lots of future technology that's focused on industrializing and high input productivity for us, but a key part of food is that microbiology. So we need to be inoculating ourselves with local, fresh, organic food. So these industrial food systems are missing a key aspect of what food actually is.
Mm.
So I just wanted to emphasize that nature and ecology has these strategies and solutions for us. We need to understand who we are as a person, like we're literally from the soil. Those organisms are a part of us. So we have no choice but to regenerate and steward the landscape for more abundance.
I love what you said right now, because especially we are in that bandwagon where everybody is moving towards a developing mentality, and then that goes on to destroy and then to disaster level, if you look it like that way. So we are moving towards a getting whatever we know as we know it, destroying the ecosystems and such, and we need to understand what nature and what nature relation we have to the nature. We are part of it. We do not own, or we are not maybe the we might be the stewards, because humans are intelligent creatures, but we are also within the system. We are not above it. So we need to work with soil, and we need to work with other aspects of nature. Maybe it may be ecosystems, it may be water, it may be air, and then let the nature take care of us instead of trying to do everything for ourselves. So that is a wonderful way that your presentation also was lovely. And thank you so much for bringing your ideas for us to share to the world, because we at Global Climate Association, what we are trying to do basically is bring the information from the natural world, from the indigenous communities, traditional systems, and scientific communities, to channelize it well, and especially ideas that are nobody really wants to talk about, and to bring it to action through different ways. Maybe it may be through education, or maybe it may through conversation. So that is a lovely thing that you're doing, and we're really glad that you were a part of this Terra Torrent series of ours to share your ideas. And thank you.